Hi guys, it's Dave from 3DP and me. It's good to be back. It's been a long time since I've been live streaming, whether it's 3D printing or Milo. Quite a few things have changed since then. As you can see, I'm in a completely different setting. This is the garage workshop. Some of you have probably seen the pictures of the bench builds, but it's nice to be in a dedicated space now instead of clogging up the office. Today we're going to go through, just checking, can everyone hear me okay? Looks like it. Just going to go through, we're going to go through the Casa build. So Milo's got a nice house now, and we're also going to go through the work I've been doing on getting Milo running on Linux CNC. So let's just do a quick recap of my Milo build and then we'll get straight into Casa. There we go, you can see it. So my Milo build is pretty stock. I've gone straight in with the metal plates on the XY and the Z. I've not got any other really fancy modifications. I have got the 120mm FMJ steel plates, 6mm steel at the back there. And I've got the square spindle. I went with the square spindle so that I could mount it straight onto the Z plate and didn't need any printed adapters in there. Although hopefully in the coming weeks we'll have a go at machining a Hearts of Iron part which gets around that for the circular spindles. I also have slightly larger LDO motors, just to give me a little extra oomph, and a different control board that will allow me to drive these to their full potential. But we'll go into that a little bit when we talk about the electronics. So, Casa. This is Casa. It is big, a lot bigger than you expect it to be. I've not changed the design or the build for Casa much at all here. All I've done is actually mirrored it because of the location where Casa is for me. If the electronics were on this end, which they are in the standard build, I'd never be able to get to them. It's quite heavy once it's built and obviously big, so not easy to move. So I've mirrored that, so my electronics are over on this side, way up here. I haven't put in a screen because I've not decided exactly what I'm going to do yet, and I need to experiment a bit with the options for Linux CNC here. I'm probably going to go with a small monitor, touchscreen monitor mounted off the top somewhere or off the side. Yeah. On the outside here, I've gone for the external e-stop, so if you do build Casa, I seriously recommend having a second e-stop. And what you want to do with these to make it safe is to wire it in series with the one in there. So if you hit either e-stop, you get the same result. And if you forget to release either one, you won't be able to start machining. That gives you a bit of safety from the outside, rather than trying to fiddle and open a door before you hit an e-stop. Over here I've got two switches. So I've got the electronics, so the control board, and all of the 24-volt circuit on one of these, and I've got the spindle on the other. Now this is useful because it means I can completely disable the spindle when I want to, and I know that I'm fully safe with that spindle completely turned off. I can go in, mess around, do tool changes, things like that, without having to worry at all about the spindle being able to be turned on or activated, etc. I can also do that without having to hit the e-stop and lose any position or disengaging the motors. Right. On the inside, step out of the way, yep. I've got Milo just sat in the middle at the moment. Not doing anything fancy. I've gone for the same lights that Tin Man recommended. These LED goes at the top, and if you're going for solid panels, you'll realise very quickly that you need them because it gets dark in there. And my light in this room is actually just above here, so it couldn't be in a much better position in terms of bringing light into the enclosure, and despite that it was very dark, too dark to really do the wiring, so I ended up installing these a bit earlier than I was expecting on the build, so I could actually see what I was doing. That came with like 5 of them. They're just little LED strips inside a diffuser. Small extrusion. And I've just got them wired simply into the circuit, so when the 24-volt supply turns on, they turn on. Originally I was going to have them wired separately, but when I realised it was so dark, I just thought I'm going to have these on all the time. So I just wired them straight in. Oh, these never go back in. Let's grab the phone and let's give you a close-up of inside Milo then. You can see what I've been doing in there. So, let's swap inputs. Cool, so apologies if anyone gets seasick, but this one's being handheld. Oh, do let me know if you can't hear me on this next section, because I'm going to be facing away from the microphone, so hopefully you can. Right, so this is my hall of mirrors. As you can see, I went with 3mm black acrylic panels for my build. These are nice in the sense that I plan on putting coolant in this machine eventually, so I don't need to worry about moisture getting on them like you would with plywood, etc. As you can see though, I've not installed any form of tray to do that yet, so there's still work to do there. It's just straight onto the bench top at the moment. In the future, I'm also going to be mounting some brackets to hold this in place. It's pretty heavy on its own, but I just like to have everything, bolted down. Same goes for Milo. It's sort of freestanding at the moment, but will get nicely mounted down. So if you look up there, you can just see what the lights are doing. I've just run the cable around the edge. All of them are wired in parallel with some nifty little connectors, and the wire just drops down to the rest of my wiring out. Over the back here, because I'm built in Casa, none of my electronics are inside the table. So basically all the wires just run down and then come out in a single bundle. So I'm just cable tied together for now. I'll probably get some sleeving to go around this, but I don't have it yet. That just goes up and through the hole into the electronics enclosure. The one exception is the little dangly cable. So this is the USB-C cable for the touch probe, the 3D touch probe. This is separate so I can connect and disconnect it when I have the probe on and off. And I don't leave the probe connected at the back there because the chips, when they pile up, are actually enough to trigger it. It just sits in a nice box over here waiting for me to need it. Linux CNC triggers an alarm if the touch probe or the length switch are triggered during a normal move, so it's useful not to have that connected. Right, got back. So, was there anything else? Was there anything else we wanted to know about on the inside of Cassa right now? Basically, my experience building it was pretty straightforward. The manual isn't quite finished yet, but it is pretty easy just to follow the CAD. Overall experience was very good. I bought all the extrusions from Ooze Nest, and all of the other bits were AliExpress specials. What I do, so I've also installed, just under here, the anti-rattle panel clips. They just push underneath and stop these panels from wobbling around. Depending on the thickness of panel you use, you may or may not need those. I will be releasing a full build video of this, so I'm not going to go into the build too much, or just introducing the features. Right. Right, quickly. So, is there any questions for the outside, or shall we jump into the electronics area? Looks like we're all good. Okay, let's jump into the electronics. Right. So, for the electronics panel or section, there is this slide up and slide down door. It's got some nice handles on the top. And basically, it lifts up and slides out. I'm just going to lift it fully out for purposes of it not dropping on my fingers during the rest of this demo. So this is the electronics area in Casa. So, as you can see, all of the wires that we saw on the outside come up through this hole on this end. My mains power comes in the back here. I have a 24 volt electronics enclosure fan. So this fan is just cooling or dragging cooling air through the front hole and keeping everything in here nice and cool. You'll notice each of the individual parts have fans on anyway, so the power supply I've got has a fan on it, as does the VFD on the top. They only turn on as and when they're needed. The Spider King control board that I'm using has mounting points for a huge 24 volt fan on the top of it. I've decided to install that, and I've set it so it turns on when the spindle is enabled, meaning that the machine's likely going to actually be seeing proper load. This means that the rest of the time it runs nice and quietly, and I haven't had any issues with the drivers overheating when I'm not machining at all, so that's going okay. What else is here? So everything's earthed, don't forget to do that, it's an important safety feature. The VFD is controlled using the 0 to 10 volt input and the forward input. I haven't bothered wiring in the reverse one because I don't really see an application right now for needing it. Up here I've just got a 24 on ground buses and then some so this is useful, this bit. So this is where I've taken the different e-stop safety inputs and I've wired them in series, so they both come in here, but the wires from the one on the front come in and then go through these little jumpers and out into the other e-stop that's on Milo and then back here, and then just the wires from there go back to my rest of my safety circuit. I've got a relay and a 0 to 10 volt board up here, so we use this to actually interface with the VFD. The VFD expects the forward input to be connected to the ground on the VFD. You can't just connect it to a syncing input pin. Doesn't work very reliably doing that. So instead we switch a relay on or off, and that closes the contact for us. And then this cheap 0 to 10 volt board that I got off Amazon. I didn't have much luck with these. I had one fail and just not output anything very early on. And then this one is hugely non-linear. So if you do a PWM frequency of what should be 50%, the value that comes out in analog voltage is miles off 5 volts. So, and if you turn the dial to adjust it to either end, the opposite end ends up a long way out of spec. So I've had to do some Linux CNC computational magic to map the actual outputs to PWM settings, which we'll go through a little bit more when we load up Linux CNC. Unfortunately, you can't see very much of the Spider King board, but under there I've got just the 3 axis installed at the moment, TMC 2209s. I will be upgrading these to TMC 5160s, the big ones. These ones, if you're familiar with them, they sort of enable me to have up to 6 amps of driving current, rather than the 2 point something that the 2209s can handle. And the big motors from LDO require, I think it's about 4 amps to run them at full capacity. So I'll be using those as soon as I get it working with Linux CNC. I do also have the option with this board to add a 48-volt power supply, and therefore I can power the motors at a higher voltage. That'll let me run them faster without losing torque. This is on my roadmap, but I haven't done that yet. When I do it, it will take up the space that the 24-volt one does now, and I'll just have a very small 24-volt power supply to power the control parts of the board. Up here you'll notice the Raspberry Pi. So with Linux CNC, all of the control aspects really run on the Pi, and the board itself is just doing the really low-level basic control, much less than the RRF boards do. So the stuff running Duet does a lot more thinking on here, whereas Linux CNC, it basically just sends and receives the signals for the I/O. And about the only smart stuff it's doing is PWM sort of pulse signals on the board itself. All of the control is done from the Pi. That's connected via the ribbon cable, which provides the power to the Pi from the Spider King, and an SPI bus connection. So that SPI bus connection is how the two boards actually communicate. They're also connected via serial, but that serial connection is just used to debug the firmware on this controller whilst you're setting it up, really, and to check that it's not doing anything weird. It's not actually used for Linux CNC to run. You can see at the back there, you've got my 2 switches for turning, basically for making or breaking the contact on the live supply to the VFD and to the 24-volt power supply. They're 2 terminals, so when I swap to 48 and have a separate smaller supply, I can use the second channel to swap both of those at the same time for the controller side. Right, what else is there to see? So that's it from the electronics. Shall we have a look at the user interface, I think? Yeah, there's my kitchen in the background. Swap to this. Good. Oh, hi Jake. Good to see you there. Hi Phil. Good to see the usual faces around. Please do drop any questions as we're going along. It makes it way more interactive and doesn't feel like I'm just doing a Linux C monologue. I really need to get a stabilizer. Right. Let's show you the user interface. So, as I said, the Linux CNC, yes. So we'll get into that, James. So I'm just going to show you the UI quickly, and then we'll get into actually getting the mill moving, because, I mean, that's what you really want to see at the end of the day, isn't it? So let's do that. So when the Pi power's on, you can have it launched directly into Linux CNC. However, I just have it launched to the Pi desktop at the moment because I'm still working on the configuration quite a lot. Down here is the little Linux CNC logo and Milo. So I'm working on basically a configuration that means from the Linux CNC side, you can just pick up and go. And you shouldn't have to change anything regardless of which hardware you pick, providing you're using Remora as your for your hardware. But it should be board agnostic, providing you're using a Remora compatible board. So I'm just going to launch it here, and we're going to execute, and it will boot up. So I've picked a relatively heavy user interface called Probe Basic. Now, let's just add my face in. Video. Oh. Right, guys, so you can see me, you can see it. So when it loads up, this is what you're greeted with. You get a much more complicated user interface than you're probably used to with RepRap firmware or a 3D printer. We have got a whole host of tabs where you can view your files. We're not actually using an ATC here, but you can load an ATC carousel in there. We have the tool library, and one of you asked to see the tool length calibration bit, and I'll show you that in a minute or two. We've got all of the offsets, so you can visualize all of the different work coordinate systems that you're working with at the moment. And you can also see a bit of information about the tool touch off. We have the probing menu, so this becomes active once you specify that your touch probe tool is loaded. So LinuxCNC tracks which tool is loaded at all points, so your programs from Fusion can load and unload the tools. If you really want to, you can program simple routines in here. So we've got facing ops, holes, drilling, you know, sort of some basic programming things. To be honest, I mostly do it in Fusion. It's just easier. You then got all of your configuration panels and your status things to view your various debug or info things. Now, when you first turn it on, let's actually swap that camera to show you, instead of me, let's show you the mill, because that's probably more useful. Where's it gone? Right, so we can see the CNC, and we can see my reflection. Ooh. And we can see, oh no, deleted the wrong one. Delete that. Add window. 1 second, I deleted the window that I was meant to be looking at. You can tell I'm rusty, it's been a while, right. Now let's bring the camera so you can see the mill just about through all my reflections over there. So what I'm going to do is just show you the sort of startup routine. So I will just check the e-stops are released before we do anything, or we'll just get errors. Right, you know what, I'll just open those doors and then you guys won't get the reflections. And start to see some movements. So when you turn it on, you have to press F1 to basically exit the software emergency stop, and we then press F2 to enable power. And you get these little notifications at the bottom. If I hit the E stop here, you can see that the screen and everything reacts to that. After I release the e-stop, with that good to go. However, the power has cut out, so you would have to re-enable the power again. Now we're going to run just a standard homing cycle. So home all the axis. You guys can see it moving around. I've got the settings for that pretty slow at the moment. What you'll probably have noticed that while it was doing that, it draws these little lines, so you essentially can track where the tool head has been. So if I start jogging this, let's see where we're going. And you'll see that the tool head moves with it on the screen. Now, what's a massive thing here that we've just done and I've sort of glossed over is the fact that that is live. So when I press the button, it moves. There is no move 50 millimeters, get stuck. It is live jogging. It moves as you press it. Now, because I'm currently controlling this via VNC viewer, via the Wi-Fi through to the Pi, there is a bit of a delay at the moment. However, when I've connected the laptop directly into the Pi, that has been very responsive. So one of my main reasons actually for moving to Linux CNC was to have live jogging, because I found tool setting and everything like that really, really difficult with only being able to do sort of slow jogging. So I find this really nice. You can set it to just move a step at a time, but right now most of the time I'll be using in that live jogging mode. Now that we've homed, what we can do, if we swap back, is we can load a tool. So right now I've got the 6mm chamfer milling. So we're just going to go in, click on that tool, click there, enter the tool number. So you see we're tool number 1, and we're going to load that tool. You'll notice that all of the offsets and tool information is used in the rest of the user interface. So we're now going to do a tool touch off, and note that the current Z offset for that tool is 31.1659. We'll hit that button. Okay, so it's telling me I've loaded tool 0. We don't want to do that, and it won't do a thing when you do that. So M6T1. So it's going to move to position. It's now going to tell me to load tool 1, which is the 6mm chamfer mill. That is currently already in place. Or I should go back a step there. So that M6T1 is the tool changer command that you'll get in your G code. So that essentially says M6 is load a tool, and T is then the number of that tool. I've currently mapped the G code macros for what happens when it receives that G code in Linux CNC to always, because we're on a manual tool changer, to always then go and do a tool probe. That's an override of the standard behavior, but it's quite a common one because a lot of people are running machines without tool holders. And we're just going to see how that goes now. So if we swap back to the phone, and I'll get you a good view of what happens when it actually touches. So I'm just going to accept the dialog box, and we're going to see it do a probe. So it is set up such that it moves to 30 millimeters above the known tool length. You can configure that, and it's sort of a safety feature. It will then do a slow move down and then a second extra slow probe move. It then moves to Z0, which is actually at the top on this machine. And then you're good to go. You've set the tool length. Now, if we look in the log files, it's going to tell you what the updated tool length is. I think if I remember before, it was 31.16 something. Let's have a look at the UI and see what the new new length is. So new length is 31.1784. Just go back to the status messages. You can see the logs. So yeah, new one saved. Cool. New tool length is updated there. It's then also said that it's not going to move to a certain position that was requested, just because that new tool length would take it outside of the movable range, and it just goes up to Z0 as far as it can go without the tool length. So if we look at the thing itself, so all of my tool length measurements, close here, are basically done from this surface in here. So where the bottom of the collet, I don't know if we can quite see under there. Too zoomy. So the bottom bit of that collet under there is the face I've used as the reference. So all the tool length measurements are done versus that. When you calibrate and set up this system, what you do is you use that face to run the setting routine. And there's a specific button that records the trigger point when that face touches and triggers this switch. And then everything else on that is done as an offset from there. And that's a good face to use, because when you're manually preloading it, you can say, oh, I've stuck this tool in about 30 mil. That way you can update the tool table and just say that tool is, I put it in and it was about 30 mil, just as your guesstimate. Just save your tool table and you'll see that the offsets have updated. We can then run that same routine again, and it will do another probing routine, and this one will basically update it. So what you should do when you load the tools like this is give it about the right range, and that way you won't crash into anything, and then do your touch off and it will update it to the exact length. And you can see here we've come out again with quite a similar length to what we had before. Is there any questions about the length settings? If I go back to DSLR. Right, is there any questions about the length setting? We can go over that now. Did that answer your questions, or shall I move on to using the touch probe? Because really the important part is that the two speak together, so you can set the lengths and then use your work offsets. But if you are using the probe to set your work offsets, you need them both to be working together, or you're just going to end up, you know, you can set the length and set your probe position, but if they don't talk to each other in the correct way, then the whole thing falls over. So let's do some probing, because this is one of the most powerful parts about Linux CNC. And it's why I picked this particular UI, because it's got all of the probing routines built in. So you can see here we've got a huge range of options. If I try and do a probe right now, when my tool that's loaded is tool number 1, it won't, basically it won't work. It will give me a warning saying tool number not in the spindle, aborting. So what I've done is I've set up tool 999 as my probing tool. And if you try and do a probing routine with any other tool, you won't be able to. It'll just block you. You get the little warnings. Annoyingly, in VNC Viewer, these little notifications don't go away very easily. You have to like click on them. But that's a bug related to VNC Viewer rather than to Linux CNC. So let's load the correct tool. So we're going to load the touch probe, so it's 999. You can tell that's in there. I'm going to manually go over and just swap those things out. I've got the big boy spindle, which means big boy spanners. So just take that out and put that to the side. One thing I have done actually, which I'll mention now, is I've put these black channel extrusion fillers on all of these grooves, because the number of times I dropped a 6mm end mill inside them and couldn't get it out, it drove me mad so quickly. So they're in every single groove I could find now. Right, let's load the probe. I conveniently had a tool that was the same diameter as the touch probe. Now when I'm loading this, I want to push it all the way up against that surface again, because that's my reference, and do it up. Now this has all been calibrated based off that reference. There is like a routine you can do. Basically, what I've done is touch off the part and accurately measure, by doing that, the offset from that face to the touch point. And I've gone through that a number of times until I got it very, very accurately. And I've gone and messed it up there. Need 3 hands. I need to design a dock so it goes down and presses it into position, and then I can come and do the spanners up. Right, so we're just going to jog above the oh, wrong window. We're going to jog above this front corner. I don't have the right button on my... Okay. And then we're going to run one of the probing routines. So let me show you that. So you can see the probing and actual probing happening in the corner, and we will pick this. So this is your probing interface. We've got outside corners, inside corners, pockets, widths, working out angles, and then extra panels and calibration panels. So this one's interesting. I'll talk about this before we do the actual probe. So to calibrate how much flex there is in the probe movement itself, you run these routines and you do it with a known dimension, and then it takes that measurement and calculates a value that corrects for the flex. You also need to enter the ball diameter as well when you're doing that. We're going to do an outside corner, and we're going to work, so you can pick your coordinate WCS that you're working in. So we're going to do G54, and we're going to probe this out front of corner. So you can see it. So the routine probes Z first. It will then back off a set amount, and that is a configurable distance. It will then do X and then Y. Now, what you should have noticed is that we now have a WCS that's updated. If I go to the offsets, and you can now see we have a G54 set of offsets. And now this is the part that you wanted to see, James, is how this ties into the tool length setting. So what we're going to do is we're going to go back to the tool window, and we're going to issue that tool command to load the chamfer mill back in. It's going to lift the tool up, go to that position. The user interface is now asking for the tool change button to happen. So I'm going to come in here and swap the tool back out. Be delicate with that, so don't drop your touch probe. Put that away for now. Iron mill. And so this was 31.16 whatever before. We're going to go longer this time. Longer? No, let's go shorter. Shorter. Do it up. We're then going to click continue in the UI, and the probe will go, the tool will go and do a touch off. You can see it doing that. So it's just going to go down with the length measurement as we saw before. I put it in too far, and this is where I need to tweak the configuration slightly. So it said that the tool hasn't been triggered the switch within the allowed movable distance. So I'm just going to repeat that. Move it up slightly. We're just going to make it slightly longer rather than trying to configure the offset values at this point in time. As you can see, this is still a work in progress. I've been a bit conservative on the values so far, just because I wanted to avoid crashing into things too much. Let's go long instead of short. I'm going to repeat that. Okay, so that has updated the tool length, and now we're at 32.8, so quite a bit longer than we were before. I feel like it should be longer than that, but let's have a look. And now we're going to move to the coordinate system that we got before. So let's go G0. So that is your X0, Y0 position. And then we're going to just jog it down, get rid of all these logs. Until we get to the basically the 0 of the coordinate system. So it should be 2.4 millimeters away right now. Looking about right, so I'm just going to go ahead and go all the way to 0. And there we have. I don't know if you can see. What is this going to look at? Won't focus on the. There you go. There we are. So we're just, as you can see, it looks like we're just marginally off the block, but that is actually the chamfer distance on each side away from the corner of the work coordinate system we just set up. So that is how the length calibration works in Linux CNC. Now, when it comes to that, it was quite hard work to set that up for the first time. However, now that it's been done, all of the touch probe work and so on is set, you should just be able to take the config files and the G-code macro files for the probing directly from my configuration. And it should be almost plug and play to achieve the same results. You'll just have to go through the calibration steps for finding the exact Z trigger length on the touch probe, and the setting the touch probe location using the UI. Where's it gone? Tool. Offsets. Yeah. So, and you do that by basically pressing this button. So you manually jog the section, so the front of that the front face of that collet, you jog that down, and then you press that button after you've just triggered the lens setter, and that basically, that's all you've got to do that, and it sets up those variables in the macros, and then you're good to go, really. So it's pretty straightforward. Right. So that is pretty much it. I'm not sure what else people want to see. You've seen Cassa. You have seen the electronics area of Cassa. You have seen Milo actually move. We've done a tool length setting and a touch probe calibration. And we have shown you the user interface. I guess what I've not done is shown you what it looks like when you load some working G-code in. So let's do that. We're not actually going to machine anything today because I didn't have anything prepared. It's more about just introducing Linux CNC, but we will do plenty of machining as we go along. So let's just load a file. I'm pretty sure I have some somewhere. I cleared them all out. Okay, let's just pick this example. Oh, so that one is the G-code visualization tool is here. As I said, let's just swap this to so you can actually see it. We'll swap that to no, just leave that. Okay, so when you're actually working with the mill, this is the window you'll use probably the most. Is your visualization of where the tool head has been. You'll see it jumps around a bit, so things like changing the tool length or changing tool gives you these jumps. You can just clear that path if it's annoying you. Let's load a different file because this one isn't very exciting. Just trying to find a nice file. It seemed to be classic, isn't it? Not having any talking about CNC mill, but doesn't have any CNC programs available. Really not finding any exciting tools here, are we? Got to be an interesting one in here somewhere. You'd have thought, wouldn't you? Right, well, let's really quickly make one then, because that is ridiculous. Transfer a file. Sorry guys, this is going to send a file over because I know I've got some on this device. Okay. Should actually have a file we can open now. We go. So you should now be able to see the G-code file. This is a pocket clearing path I was doing. You can also see the 6mm tool bit that's been loaded. It gives you a really basic geometric representation. When the mill is moving, you see the position update live here. Why are you not doing anything? Oh, sorry, I'm in auto mode. There we go. So you can see the mill moving. What these buttons here do is set the limit of the move. So if you want to move a maximum of 50, you can set that. I think I'm going to increase one of these to be the full length of the travel, so you can move the full thing in one go. Then retain the other smaller increments. Lets you jog around. So you can see here. So when you're actually executing a program, these toolpaths will happen live basically as it's running. I wonder if we can demo. I think we can. Let's do an actual demo of the mill moving and visualizing the CNC. So I'm just going to take that block out and set my offsets so that it doesn't clash with anything. And then we can probably run the mill. So let's just jog around and make sure we don't hit anything whilst we are. In fact, I'm just going to move the center point of the offset that we're working on to here. So we're going to go down here and just in the coordinate system we're in, G54, we're just going to 0x to put us in the center. And you'll see now when you go back here, the G-code has us in the middle of all of the bits. We're also just going to raise the height of that offset so we don't crash into the vices as well before we run this. Set Z height to 10 because we also don't want to crash into the Z limit, right? And then we're going to have a look at what it looks like when it's running. So, e-stops aren't killed, power's on, so you can start the job by running it from here. You can also run a line at a time or blocks of code if you have split your program down into blocks. You can also pause the feed without turning the spindle off, and various other control options here. So, as you can see, when we're running, the preview shows you live where you are, moving around the toolpaths, providing... I've not been showing you the right window. Shout at me, people. Right, so we're running, but now you can see the mill's moving, you can see the tool bit moving and which part of the path you're on. The G-code window shows you live which line you're working through. You can see it moving around. What you will notice, I didn't have the spindle actually turned on. Right now I don't have any sort of safety catch which will essentially work out that the spindle is not turned on. If I do, things will probably get noisy. But we'll leave it off for now. What is interesting is while that's running, you'll see that the cooling fans for the Spider King and the enclosure have turned on. Because I turned the spindle on after the start command was already called, the spindle is unhappy. You have to make sure that it doesn't have any settings that would turn it on immediately before you turn it on. So you can't have the start forward thing active and then turn it on. The e-stop, if we practice that, will kill the machine as expected. If the spindle was on, it would turn the spindle off. When I release the e-stop, we do not get it immediately starting again, which is good. You have to re-enable the power in the UI. And then you have to click cycle start again to get it to continue from where it was. Stop that. Okay. Hi Alex, how you doing? So that is pretty much everything. Like I said, we're not going to do any milling today. I've not got anything prepared. Does anyone want to... What would you like to do now? So is there any features you think I've missed that you want me to go through? Any features you want me to go into in more detail? Let me know and we'll cover that. Otherwise, I will probably call it a day. So, let me know in chat now. Right, well, everyone seems quiet, so I'm guessing more questions have been answered. The only thing was someone in Discord was asking about parts earlier. So far, since I got Linux CNC working on this, this is the biggest part I've machined. It mostly went okay until I tried to do the profiling operations and I broke my ball nose end mill. There's a big chunk of material removed here. I've got some good pictures which shows the entire floor of Milo covered in chips. It was very satisfying not having to clean up the entire garage whilst running that. I was just able to, open the doors and vac it up, which was very nice. I do recommend getting an enclosure when you're ready. And I just want to show you guys this because this is a good demonstration of the fact that this is actually a mill that is very much capable of machining aluminium. It doesn't have to tickle at it. It doesn't take days. Just gets through it. So it's quite good. Yeah. So I'm quite excited to see what we can make going forwards. I have the stock for got some stock for some hearts of iron, so I'm going to be doing hopefully 3 sets if all goes well, but probably 2 because we all need the learning set. As in, I've got a load more. It's enough for one half. And I will be doing giveaways in the future streams of those. We'll also be streaming them live. Jake is going to be coming to join me here in the workshop, and he's going to be going through machining hearts of iron for you. He's going to be talking about why it's so important and all the benefits it gives you. So I'm really looking forward to that joint stream. And lastly, if nothing else, if you are in the UK or like to travel, we as a team, the Millennium Mill team, will be going to SMRF this year. So that's the Sanjay Mortimer Rep Rap Festival. It's in December in London. Come see us in person. It'd be great to have a meet-up. So, on that note, Jake has another present for me from LDO. Is it a secret or is it, can we talk about it? I need a camera over here. My screen is miles from where my camera is. Let's move to chat mode camera. There we go. You can see the rest of my messy garage. Still got a lot of work to do on the rest of the walls. I covered this one up, but I still haven't put the tools on it yet. Let's keep it until the stream. Okay, no worries. I'm looking forward to it. It's we were meant to be doing the stream Thursday night, but unfortunately we had to cancel the double stream ahead of time. But we're going to get that back in the calendar. And in the next stream we're going to actually do some machining. I'm not sure I'm going to go straight into the hearts of iron. I think I'm going to save that for when Jake's here. I think what I'm going to try and do is a demonstration using multiple coordinate systems. So we're going to end up running with both vices. We're going to set up a WCS for each one. And then we're going to run 2 parts with the same G code on 2 WCS, hopefully. Hopefully. But yeah, anyway, I hope you guys liked it. If you've got any questions about my setup or the Linux CNC implementation, just let me know. Yeah, good to see you guys. Have a nice day. See you in Discord.